tender stage support, and early concept demolition. Okay, so let's make a start. So if we boil it down, what is tender stage or early concept support? What is it? What does it look like? It's identifying the most appropriate demolition strategy early on so that the right planning can be made in good time. It's understanding the risk and trying to design out risk right at the beginning. It's identification of temporary works, establishing a temporary works register perhaps, producing drawings or sketches to communicate that concept to either the subcontractor or the client or a third-party stakeholder. And then we also supply a quote that will outline fees associated with the design that can then therefore be incorporated into the tender or early stage support. And as part of identifying the most appropriate strategy, that could involve how we can eliminate temporary works through some smart sequencing and using the existing structure or the permanent structure that's going in to take some of those temporary loadings and essentially eliminate temporary works. And actually that is more of our focus at Andun and a part of our kind of mantra of no temporary works is the best temporary works. And where we do this at concept design, this is where we can provide the most significant savings. And the support ultimately enables better program and cost certainty and reduces the overall risk as early as possible. So what are we aiming for when we say concept design? We define it as a design solution that has a design output, which is usually visual drawings and sketches and things, or it could be tonnages, for example, for a facade retention scheme or something, and a ballpark design. So the minutiae of the detail is not supplied, but we need to be really confident in that solution and be able to provide some supporting calculations to demonstrate that it's going to work. The proposal is on the conservative side, but it still needs to be competitive. And that's the really fine balance point, which comes down to competence and experience, because we want to be efficient and we want to be competitive. Of course we do. But we don't want to be hoisted by our own petard. In other words, we don't want to design something that works, but could be blown out of the water by an assumption or issue that's likely to require a more involved or a heavier solution further down the line, because that's going to mean that the work that we need to undertake on site when we actually get to the job could potentially take longer or cost more or reduce the margin of safety. Certainly not what we want to do. So a quick example of a tender concept coming through those design stages is shown here. So what we've got is a basement demolition scheme and redevelopment of a basement, the construction of a new structure within the basement, but that was deeper than the existing foundation. So there was quite a complex demolition / construction interface. The deliverables at this stage, at concept stage, are sketches as shown here that communicate the general proposal in sequence. Then this was supplemented by a quote, and in this case, an in-person meetings and presentation to present the concept to the client and sell the dream, as it were. So the route of solution that we go down is very specific to the project, the structure, its constraints, the time that we've got to deliver the project and design life, and the location as well. So there's so many variables involved which are considered, and then multiple sketches and ideas are produced on scrappy bits of paper in the office, and these ideas are discussed and evaluated in the design team, which generally leads to a kind of a standout concept, which is then chosen, and that's what we share with the client. And once we've agreed on that concept, then a preliminary design is put together. This is in the form of CAD drawings usually, which shows tonnages and sequence and extents of temporary works and any residual risks, and generally a lot more detailed than the sketches that we were kind of communicated to the client in the first place. And that's going to enable procurement to be lined up and programs to be written, even subcontractor RAMs start to be drafted up to. And this gets the project all moving along in the right direction, with all parties buying into and feeding into that proposal. And once that preliminary design is complete, then we can look at the detailed design, the check package as well, with fabrication drawings produced, etc. And what was the original concept sketch is now ready for the construction stage, and that's what we've got here. We've got the real thing, and if we compare to the original sketch of what we had, that's pretty damn close. That means that the pre-planning work that we carried out doesn't have to be reworked, and the site activity becomes much more smoother process. Producing a good tender or early concept scheme comes down to understanding the problem in the first place and having the experience and the foresight to know and understand the problems that you're likely to face going forward. If you don't understand the problem, then you have no way of providing the correct solution. And that's really important. If you don't understand the problem, then you're not going to be able to provide the correct solution for what we've got, the task at hand. Engineers are problem solvers, and we love a challenge. I talk about problems a lot, and not in a bad way. I sometimes call them fire juggling monkeys, after the monkeys and pedestals business concept, if you know that one. But these problems are challenges that we need to overcome with, and we have a fair bit of experience of that at Andun. So if we delve into the benefits and understanding of these challenges that a project may bring early on, understanding it and planning it at an early stage, we can look at this chart, which is from a constructability guide provided, published by Temporary Works Forum. And if you can see on this chart there, on the bottom, we've got the project timeline. Up the left-hand side, we've got the level of influence that we've got on the project. And then on the right-hand side, we've got the cumulative cost. So as we can see at the very early stages of the project, nothing's been built, everything's on paper, and we can have a lot of influence in design changes, and it's not going to cost us a lot of money. Whereas when we move through the project timeline, then it's going to cost a lot more to make changes, and the extent of changes that we can make becomes very limited. Otherwise, we've got to go down the lines of removing work or demolishing work that we've already done, and that has a large influence on changes that we can make. So you can see that chart shows that later on in the design, well, later on in the construction, we can do very little. So that's why it's really important to have that impact early on and make those smart decisions early on in the project. And these publications focus on temporary works and constructability, making sure things are easy to build or in some cases demolish. And there's another great source of information by the Safe by Design group, and the words constructability and temporary works here cropping up again. Because what we're trying to achieve and accomplish when looking at tender stage or early concept demolition is the following, really. So we're looking at producing something, a building or that's buildable or constructible, whilst trying to eliminate the temporary works. And if we can't eliminate it, then we reduce them as far as possible. We try to make them more cost effective. We try to improve the program or provide program certainty and reduce carbon cost or increase safety. And then depending on the project and depending on the drivers of that particular project, then one of these may well have a larger influence on the proposal. It just depends what the driver is. A couple of examples of this on a particular project, which is in North London at Upper Holloway Bridge. It was a bridge redevelopment scheme. I'm going to show you what a tower of children's building blocks has to do with the temporary works schemes that we came up with in this project. So to enable the construction of new abutments of the services bridge, we installed a king post pile wall in the existing cutting. So the services bridge was going to go alongside the existing bridge, enable the services to be diverted into the new services bridge, which would then enable the existing bridge to be demolished and replaced. So the king post pile wall was going in the existing cutting, and the posts were installed with an excavator with a Movax attachment, and the excavator was located mostly on the path, on the footpath of the existing bridge. And this footpath was riddled with services. And so the original idea before we came on board was to cast a reinforced concrete cover slab on top, which would then protect the services, distribute the trap pressures down to an acceptable level. Instead, we proposed to use timber mats that spanned over the services, and those timber mats sat on the roadside and also onto the spandrel wall on the bridge. And this is where that children blocks kind of analogy comes in. So this solution not only did away with the reinforced concrete slab and loading the services, albeit to a lesser extent, but it also stabilized the wall. Much like when you've got a tower of building blocks, the wall was in a much more stable condition as it had a stabilizing force holding it down from above, and much harder to push over a tower of blocks if you're pushing down from the top. And if we review this proposal against our list that we've got here, eliminate temporary works. We couldn't eliminate them, but we did reduce them as far as possible. And we made it more cost effective compared to a temporary RC slab. It was a cheaper solution using proprietary mats. Improved program, tick, yes. It was much quicker to lay down and remove the temporary timber mats as opposed to construct and then demolish a RC slab. Reduce carbon cost, tick, and increase safety, tick. In this case, because we could stabilize that spandrel wall as opposed to just sitting the excavator behind it and loading it. We also did a similar thing with the mobile crane on this same job. This mobile crane was used to install the services bridge, and putting a crane on top of the abutments and the outriggers on top of the abutments essentially stabilized them as opposed to surcharging them from the side. Bringing the crane closer, requiring a smaller crane, a better view for the crane operator as he's driving and carrying out the lifting works, and less temporary works overall. It was just, it was quite fortuitous really that the crane that they were using fitted like a glove like that over the abutments as we skewed it slightly. But yeah, that was very helpful. But this strategy is not a new idea that we've come up with. No, sorry. Engineers have been doing this kind of thing for years, providing that stabilizing force and increasing that stability of, in this case, as you can see, that's Canterbury Cathedral, and that's in Gothic architecture to reduce the destabilizing load that you get from a thrust point on an arch by adding heavy pinnacles and statues on top of them. More details on that subject, I'll refer you to our video that we've got on medieval engineering on our YouTube channel. It's a good one if you like castles and old engineering wonders and engineering behind those. Moving on. So, benefits of that early consideration of constructability, demolition strategy or temporary works can bring a reduction in risk due to better planning and leading to increasing of safety margins. It can lead to cost certainty, which clients are very keen on. Cost efficiency, again, clients very keen on that one too, surprisingly. And carbon reduction and program savings. So there's a number of reasons why that early consideration and early planning really do pay off. We've got a few case studies which we're going to demonstrate some involvement on various projects that we've had. And our first is going to be presented by Dave. So over to you, Dave, looking at the next case study.
Yeah, so I'm going to have a quick chat about staying on theme, like the kind of the tender or early support that we had in Frederick's Place and the basement propping specifically. So the project was, we worked for the demolition contractor Salters, and we also worked for the main contractor Knight Harwood as we followed on with the works. It's a site very close to Bank Station. It involved the complete demolition of the existing structures, the deepening of the existing basements, and then the construction of kind of almost three new structures on the site. So if Josh clicks on, you can kind of see the site during or following the demolition. There's a lot of constraints. We're very close to a lot of other buildings, and the deepening of the basement was going to be quite a major headache for everyone involved. So, and that was the intention afterwards, was to get it to this kind of nice structure overhanging or kind of with a walkway over Ironmonger's Lane. We did, the basement propping, did a lot of the party wall support on the buildings adjacent, and then we've had kind of follow-on work with the cranes that are on the site, and it's almost topped out now, so the building is almost complete. So the basement propping specifically, we provided some very indicative schemes right at the start to give people an idea, and this is the kind of what Josh was talking about earlier. We have kind of rough steel sizes so you can work out tonnages, a general layout, kind of where we would need more information. So there was a return wall that we could use for, or to reduce the amount of propping and make it easier to construct. So we kind of, and we produced this sequence. So if we go on to the next drawing, you can see that we were going to kind of put some wailers in at high level, have a berm up against the walls, and then a new slab in to support further raking props. After that, following the removal of the berm, you could then deepen the rest of the basement and kind of come and then install some further propping to build right up against the walls. So I've got a few pictures now of, just so you can compare between this kind of tender early concept to what was actually constructed on site. And like Josh said earlier, it's never exact, but the general concept was reasonable. We got it to work after further calculations and detailed design, but yeah, it was a good project, and that kind of early involvement helped everyone involved understand what we were going to do. So that's kind of a bit on yet another basement propping project, but where the early involvement can be very useful. So the next project I'm going to talk about is a bit different. It was the dismantling of a container crane up at Greenock. So here the demolition contractor was Sam Evans, and the overall client was Peel Ports, and the scope of works was to dismantle that container crane. So Peel Ports were kind of renovating their dockside. They have 2 new container cranes turning up, and they needed to dismantle this old container crane. There was one drawing of the crane which did not have any section sizes on it, which made the job quite complicated. So our scope of works was to survey the crane, carry out a weight takeoff, and then do a dismantling sequence and stability assessment on the crane. So that survey work was quite difficult. We needed to get on site, take measurements of each of the members in enough detail to be able to draw it up and to produce an accurate weight takeoff for it to be dismantled. So just some pictures there kind of illustrating what we were doing, how we went about the job, and yeah, how we did the weight takeoff. Following on from that, we completed a 3D model of the crane so that we could then work out centers of gravity of various elements. And then from that, we could then carry out our demolition sequence. So we were working from alternate sides essentially to take weight off the crane evenly so that it remained stable during the dismantling process was the basic principles. And you can see from the drawings, there's just a nice sequence showing lift weights, any interesting things on each of the lifts and all their centers of gravity, and just a nice dismantling sequence. Less tender involvement here, but also quite an interesting little demo sequence. And I believe we have a video that may or may not work.
I think that's going.
Yeah, it is. So this just shows the kind of the crane setup and then the dismantling sequence as it happened, and a bit of the cut sequence. So taking off the machine room at the back, taking off the jib, and then working through the back spans and taking them off. And after that, it was quite a stable structure to then lift down. The lifts got a lot heavier. So see the final bits of the dismantling sequence. The job was fairly successful for everyone involved. The only thing that caused issues was the Scottish weather, which on the west coast near Glasgow was always going to be an issue. But no, overall, a very, very good, interesting project that we carried out this year. So I think that covers me. So I think, Josh, you're going to do another case study on some
Yes.
stuff?
Yes. So thank you very much, Dave. So we're going to look at another case study here, which shows an example of tender to completion. So this project includes top-down demolition of two linked large panel system structures slap bang in the middle of Coventry city centre. The client was Coventry City Council. The principal contractor was Coleman and Company, and I was the lead designer and temporary works supervisor on site on occasion. I worked really closely with the site team and regularly visiting site to carry out investigation works and various inspections and things. And the building itself was a local landmark and was being cleared to make way for council plans to regenerate the city centre. The ground level of the building was incorporated into the high street, and restaurants and shops all at ground floor. There was also a link bridge that led from one of the towers to a multi-storey car park, which you can kind of see on the picture on the right-hand side there. So as you can imagine, there is lots of constraints associated with the proximity to the public, as the shops and all around the buildings were to remain open. And not forgetting that this was a large panel system structure with its inherent risks associated with stability and robustness and risk for latent defects as well. So there were key drivers in the chosen methodology of demolition. And that was all really pointing to one direction, really, which is top-down demolition. At tender stage, we had a fantastic brief and an understanding of what the contractor wanted as part of their tender submission, and it was principally using our knowledge and experience to develop a demolition methodology that would work on site with all the constraints involved. There were lots of information, so it's really helpful that the brief identified the relevant information so that we could save a lot of time in going through all that information that we got on there. So we can see some of my preliminary sketches on sequence and proposals that then were developed from some kind of back of the envelope type sketches to a 3D demolition sequence, which was supplied at tender stage 2. This showed the proposed sequence, road closures expected, required, location of welfare, hoist location, craneage, and when that's required and comes in and where is it going to go. It includes some illustrations of the temporary works as well that was necessary, such as propping requirements and expected demolition plant, the type and sizes, etc. We also looked at the scaffolding strategy as well and developed that, illustrated that on drawings, which is shown here. Knowing what the scaffold would look like, or at least an idea of what it would look like, and developing a scope that could then be priced up by a scaffold subcontractor, and then also feeding that into the tender submission. This all contributes to better cost certainty and risk reduction in terms of, you know, what it's going to cost later on the project when you get down to actually doing the job. How the demolition material was going to be removed as well during soft strip and the demolition was planned out. Because as with top-down demolition especially, what takes time is getting rid of the debris, not actually the demolition itself. It can be quite quick to make a big mess, but then clearing up can take some time. And we wanted a fast system of removal that had some redundancy in it so that the demolition activity of actually taking down the structure wasn't held up. So for the full process of the demolition needs to be thought through, including temporary works requirements as well. There are several temporary works items that were required on this project, just picking a few there: global stability, comprehensive site investigation review and desktop study, which is very important because this structure was a large panel system structure, and that desktop work included contacting Bison, who were the manufacturer of the panels that they used there, just for some inside information and to help us out. Plant justification, scaffold checks, etc. And then a price for the design fees that would be associated with this finalized design work was also prepared, which could then be included in the tender submission. We've got some photos here of the job when Coleman's were actually carrying out the demolition works, and the scaffold going up there. It was a very tall structure, and standing at the bottom, you could really see how we needed to mitigate the risk of anything kind of coming away and outside from the top and into the public realm. We've got some push-pull props on there as well for keeping those wall panels stable as we remove the head restraint of the from the top slab as we were coming down the structure. And some plant operations shown there. We're carrying the floor by floor demolition, and then some methods on controlling that debris, like I said, to prevent the debris kind of coming out the side of the scaffold perimeter and into the public realm, which is really a key driver for the demolition methodology that we proposed during the tender. Here's a photo of the structure as it's getting shorter and shorter and shorter floor by floor. So I took this photo from the car park nearby, and you can see that it's pretty close to some surrounding buildings, which were a key constraint on the project. And then that's it, floor by floor, bit by bit, and then it gets till it gets down to the last kind of shorter part of the structure. So you can see there, that's the kind of mushroom head. That was the podium level that was demolished by some large excavators all working at ground level. So some key points to assist at the project at tender stage was really understanding and therefore reducing the risk and identifying the temporary works that would be required on a particular project. So it's to plan ahead, understand the risk, and to get most out of the tender, which is why and what really early support and concept design is all about in a nutshell. There are many benefits that can be gained from this process, but it requires some forward thinking and planning ahead. And then we can reap the benefits such as risk reduction, which can potentially lead to increase in safety, cost certainty, cost efficiency, potentially carbon reduction, depending on the drivers on the scheme, and also program savings. So thank you very much for your time today. I hope that what we've shown you today, some little snaps of and insights, and I hope that you can take something away from today that's going to help you in the future. There's lots and lots of information that will help kind of redefer or help more focus on certain areas. So there's Temporary Works Forum website there. There's a host of information on there. A couple of documents that I referenced earlier regarding constructability, being Constructability, a guide to reducing temporary works by the Temporary Works Forum, and also the Safe by Design group publication, early focus on constructability in temporary works. The NFDC have a great guide on demolition and temporary works, which I've shown a picture of there. That's a new edition of it. And another source of information is the Institute of Demolition Engineers, the IDE. And not forgetting, how could we forget, the 60+ videos that we've got on our YouTube channel. There's loads on there, all temporary works based, demolition, rail, cranes, working platforms, facade retentions, lots of case studies on interesting projects, hours of content,